We have Mihail all the way from Europe. How are you?
I'm good, thank you. Hello,
Woohoo! So
everyone.
it's morning where Mihail is, so this is
It
perfect
is.
timing. He's not lethargic or sluggish from the day. He's ready to give you all a fantastic presentation. So Mihail is from Pulumi, and we'll be using Pulumi in the presentation to talk about how to use that to do some really amazing Azure management superpowering. So we're super excited to have you here, and I'll feel free to share your screen, and I'll hand it over to you.
Thank you. Hello, friends, fellow .NETers. Since you joined the .NET Conf, I suppose you probably developed some sort of applications with .NET. It could be like web applications with front end and back end, maybe some data processing, maybe microservices. In any case, you need to deploy those applications somewhere. And it's 2020, so it's likely that this somewhere is probably some sort of cloud and possibly Microsoft Azure. So today I want to show you how you can reuse your existing skills of a .NET developer with C Sharp, maybe F Sharp, to provision cloud resources. And I'm a software developer working on a tool called Pulumi, which allows you exactly this, deploy Azure resources with .NET. So three cool things that I want to emphasize today with Pulumi is that you can reuse all the skills and tools and habits of from your .NET application development world to this new environment of deploying cloud resources. Two, you can get access to the full API surface of Azure and also Kubernetes if that's your jam. You don't have to use Kubernetes, but if that's your case, you can use both of them at the same time with Pulumi. And then three, my demo will show that Pulumi works as of today with all the greatest and latest tech, .NET 5, C Sharp 9, F Sharp 5. So let's get started. Of course, you might know that Azure has, at this point, dozens of services and hundreds of resource types. This is just a small subset of those on this picture. And you probably start creating those with like getting started guides and Azure Portal and whatnot. But definitely Azure Portal is not a suitable tool for any kind of production deployment where you need reproducible, repeatable deployments with a history and like reliability of automation. So you might have heard of infrastructure as code as a concept, where the idea is that you describe your resources as in some sort of machine readable format, and then there is a tool that takes your machine readable files and deploys resources automatically from those definitions. And you may know ARM templates for Azure, where this machine readable format is JSON. In Kubernetes, that would be YAML files and things like Helm templates. So what we at Pulumi suggest is that you modernize your approach from text files to using general purpose programming languages and runtimes like .NET. And the benefits are, for example, that you can use all the rich tool chain that you are used to, like compilers, IDEs, refactoring, and so on and so forth. Then importantly, you can create reusable functions, classes, and libraries to define new abstractions and share it with your teammates and larger community as well. And on top of that, you can even do things like unit testing, for example, where you write your infrastructure code in C Sharp and then you write unit tests to test their definitions fast and reliable from within your Visual Studio or other IDE. How cool is that? So Pulumi actually supports multiple cloud providers, AWS, Google Cloud as well, and others. But our Azure story is special because just a few weeks ago, we introduced a brand new Azure Next Generation provider. And it, of course, supports all the latest .NET languages and runtimes. But even more importantly, our .NET SDK is fully automatically generated from Azure Open API specs, which means that as soon as Microsoft publishes some new API specs for a new service or a new resource or a new API version, we take those specs and automatically generate SDKs for you, which means that you always have access to the latest and greatest from Microsoft, basically on the same day when they are released and publicly available. And we even have a tool that can take an ARM template, a JSON template, and then automatically convert it to a C# program that you can take as a draft and adapt to your needs with relatively low effort. So here is the first example of a program, or rather the resource definitions in Pulumi with C#. Each resource is basically a constructor call with a name and then a bunch of properties depending on the resource type. In this case, I defined two resources objects, a resource group in West Europe, and an app service plan. And note how I use the resource group variable in the definition of the plan, and that the usage of that variable for app service plan properties automatically defines the dependency between resources. So you don't have to define things like depends on in ARM template. Well, we will execute the whole program and then derive the dependency chain just based on your usage of variables here and there. Now, a lot of companies these days start using Kubernetes as their application platform. And with Pulumi, it's the same story for Kubernetes as for Azure. You can manage 100% of API surface area, and as soon as the new Kubernetes version is released, you get full support on the same day. And you get the benefit of being able to deploy both Azure resources like AKS cluster itself and Kubernetes resources like services and deployments from the same program, the same .NET solution. And all that with safety and pleasure of working with .NET to define them. Pulumi SDK, .NET SDK has launched about a year ago with .NET Core 3.1 and previous versions of .NET languages, of course. And it's always been cross-platform, so I'm on Windows right now, but I use it on a Mac basically every day. And I'm happy to announce that we support .NET 5 and C# 9 as of today, which I'm going to show in the demo in just a second. And actually, that's about the end of my slides. I'm going to switch over to my Visual Studio, where I have a sample project ready. And you can see that this is a C# project. It compiles to an exe file, and it's already using the .NET 5 framework. And it has a bunch of NuGet packages references, and they are all Pulumi something, so they are all different providers to Pulumi that I use in my sample application. Now, this is not a clean, this is not an empty solution that I just started. I already prepared several components to show you the power of an expression of C# applied to infrastructure. So I have several components, but my program.cs is completely empty, and I have some to-dos for myself to bootstrap this program to actually deploy some resources for you. So in order to do this, by the way, I can start using the top-level statements in C# 9 right away. So I'll start typing my main method without any classes or methods here. And all I need to do is to call Pulumi deployment run async. It's the method that I have to call to initiate the deployment from my console application. And what I pass to it is a callback that's going to be called at the deployment time. And that's here where I have to define my resources. And so that's basically step one done. I bootstrapped the deployment of Pulumi program. So step two, I want to deploy a simple web application that would run just a pre-built container from a public container registry. And this is the name of the container, basically hello world HTTP application. So to do that, I need to define a single component. And again, I already prepared several components, so it's going to be just a couple of lines of code to simplify the demo. But I have this web application component that I can define. I can call it like a hello world or something. And then again, a C# 9 feature where I can use implicit constructors here, just new. And then I type some properties in here. And the only property I have to specify is basically to say what my Docker image has to be. I can copy it from down below. Say, hey, I want to deploy this container image as my web application. And the last thing I need to do here is basically return the URL of that application that Azure is going to provision for me from my program so that I could test it out afterwards. So for that, I can say outputs. Output is a result of the execution of Pulumi program. And then my app component already has an endpoint property, which would point me to the exact URL of the app. It doesn't exist yet, but when it's provisioned, the URL is going to be returned. So that's my program for step two. And to execute this program, I need to jump to some sort of CLI. I have PowerShell open, but it can be any bash or whatever. And then I'm typing a command Pulumi app, and I'm in the same folder where my C# project is. So what this command does first, it would compile my project. It will then start my project, and it will show me the preview of what about to happen in Azure if I agree. So it detected my web application component, and web application component knows that it needs to create a web app in Azure. And for that, it needs two resources actually. One is app service plan. That's where I deploy my web application to app service. And then the second is web app itself. And of course, it also needs the resource group to deploy. The resource group is just another type of resource in Pulumi. So I'm happy with this preview. Nothing happened yet, but if I say yes, then the same happens again. My program runs again. It defines the same definition of resources, but this time Pulumi actually goes ahead and starts deploying them. And you can see that the order of execution, I didn't have to define it explicitly anywhere, but it starts with the resource group. Of course, it deploys the resource group to Azure. When it's done, it starts with app service plan. But you can see that web application is still waiting until app service plan is provisioned. Now it's done. So web app started to create. And then when this is done, the program will be completed, and I should see the URL of my web application appearing on the screen. So this is the flow of working with Pulumi programs. You change your program, you go to CLI, you run the CLI, you get the results. So this is my output of the program. It's some URL at Azure websites.net. And if we switch over to the browser and try this URL, it usually takes like a minute for app service to load here. But yeah, maybe I'll just jump back to my ID and continue step 3, and then I'll show you that app service actually started, just to save some time. So my step 3 is actually do the same, but I want to provision custom Docker image, not the pre-built image by somebody, but I have an application folder on my disk app where I have a Docker file inside, and that Docker file points to like another hello world application that knows to return where it runs. So if it runs in app service, it will return, hey, I'm running an app service. If it runs in Kubernetes, it will say, hey, I'm running in Kubernetes. That's all my application, but it could be any application of yours. And then what I need to change here for this step 3 is to use, instead of the Docker image that I pointed to, I can say that my app folder is this, just app on my disk. And that's enough to say to my component that instead of deploying a pre-built image, it should actually go and build that image for me, deploy it to Azure Container Registry, and then point my application to that image in Azure Container Registry. And now you can see that the app service is actually up and running, and I'm getting hello world from development. So the step 2 completed. Now let's run my program again. And this is to show you the power of basically desired state configuration that I'm using here with infrastructure as code. What happens now is that Pulumi compares my previous deployment state with the new state, and it figures out the exact difference that has to be deployed. It knows that resource group can stay, app service plan can stay, web app can stay, but it has to update my the pointer to the Docker image. So I see in the preview an update operation for my web app. But now I also need 2 new components, which is a registry in Azure Container Registry, and then Docker image itself that will be published to that registry. So I hit yes again, and this time it deploys exactly the difference between the first deployment and the new deployment, again in the proper sequence. So it should start with a container registry, of course. In parallel, it's building the Docker image, but it cannot publish it until the registry is done. The registry is done now, so the image is being built locally and then published to my new private Azure Container Registry. And then when this is done, it will be time to update a web app to point to that new registry, new Docker image. So every time you change your program, you go ahead, you compare your preview with what you expect. If it's okay, you hit yes, and then only the difference is being deployed by the tool. So now, again, probably it will take a minute or so for app service to refresh with a new Docker image. So I'll just go ahead coding. to save some time a bit. And the next step is actually to deploy the same application, but not to app service, but to a custom Azure Kubernetes service. So again, I have a component handy, which is called AKS cluster. And if I type a new AKS cluster in my program, I should create a new AKS cluster. And that abstracts away all the mechanics of creating one. There are some optional options there. So if I want to specify VM size or something, I would be able to, but now I can just take the defaults. And then my web application accepts another parameter cluster if I want to deploy to the cluster. And that's all I need to change to start deploying to AKS instead of app service. And you can see the power of abstractions here. So you can imagine a team where some person is more specialized in creating those components like web application. They know how to encode your desired behavior into raw Azure resources. And then all the other members of the team could use just those components to sort of operate on a higher level of abstractions and don't care too much about the nitty-gritty details, right? So let's first change, yeah. So app service updated. Now you can see that my custom Docker image is running in Azure app service instead of the previous image that I had before. And now I'm running Pulumi up again. It will execute my program again, and this time I should see a lot more resources because now AKS needs to be provisioned and some Kubernetes objects as well. So let's see how that looks like. So in the preview, I see two groups now. I see my old, oops, yes. So I'll go ahead and start deploying because Kubernetes takes like 4 minutes to deploy, but I'll go walk you through the deployment at the moment. So I have two high-level components here as expected, a web application and AKS cluster. An AKS cluster requires some mechanics like provision an Azure AD application, some service principals, TLS keys, all the details that your infrastructure team probably cares, but your application developers don't care too much. So all of those will be created automatically by Pulumi. And then web application has now changed from app service that's going to be deleted. You can see on the right that app service plan and web app are going to be deleted after the deployment is complete. And in addition, instead of that, we get like a role assignment resource that grants Kubernetes cluster access to our container registry, and then two Kubernetes objects, a deployment and a service with a load balancer type, so like a way to deploy a web application in Kubernetes. And the deployment will proceed in a way that it will start creating a cluster, and my web application is still up and running. So if I'm like running V2 of my application at the moment, V3 is being deployed, but V2 is still up and running, and the deletion operation, the destruction operations will be the very last ones in the sequence. So cluster is being built. Again, it takes maybe 4 minutes to do so. So I'll jump ahead to my IDE and show you the last step that I prepared for this demo. And it's actually a cool one. I have a short snippet to avoid too much typing. Hopefully works, yes. So because we are using a general purpose programming language as C#, we can do some cool tricks like applying the same pattern to all the resources in the stack. So what this snippet does, it says that, okay, I have some stack options that I'm going to pass here in the constructor. And those stack options instruct me, or rather instruct Pulumi, to do something for all the resources that it provisions. In this case, it says I want to transform all the arguments. That's a bit of advanced concept, but it's pretty cool, so I want to show it. So it would transform any resource to have tags in there. So I don't have to tag every resource manually in my program. If I want to have these tags on all Azure resources that are ever provisioned with this program, I can say, please auto tag all the resources for me. And these are the tags that I want you to put on all the resources. And when the program runs, you can imagine that this callback is going to be called every time a new resource is defined. It will look at the tags and say, hey, do I have owner tag here? No? Okay, then I'll add owner tag. Do you have provision by tag here? No? I will add it. And if you have 5 resource groups, for example, they will all be tagged automatically by this small snippet of C# code. And that's not just one specific function that I can apply. I can do pretty much anything that I can do in C# with the shape of resources. So that's the power of a general purpose programming language at your fingertips. And again, I just pass these options to the run async command, and then it would modify the options that my resources get. Let's see how it's going with my cluster. It's still being provisioned. So maybe I'll show you how my components look like. So here is an AKS cluster component. I wrote it myself. So that's not something pre-built. That's my application-specific component. And it has, again, a new C#9 feature record. It's using the records for args. So I get a couple of args like VM size, VM count, Kubernetes version. Of course, it could be like 10 args or so. It doesn't matter, defined by what my application needs. And the AKS cluster is a class. So that's how you create abstractions in C#. You derive from a component resource, which is a Pulumi class. And then inside the constructor, you start creating resources one by one. So application is a resource. That's Azure AD application. Service principal is a resource. It gets a name and some parameters. Again, C#9 features here. I generate a random password for cluster admin. I create a service principal, TLS key. It's all the machinery for the cluster, and finally the managed cluster. You can see how this structure immediately transfers to the preview that we saw before. And every resource here is basically a resource there. And the cluster is sort of sophisticated resource that I use here to provision AKS cluster. And it's maybe interesting to look at the top here, because based on the using, you can see the structure of our provider. So Azure Next Gen is what I'm using to provision these resources. And then if I were to use something else in Azure Next Gen, I can use IntelliSense to like navigate all the modules. Maybe font is a little bit small, but like I can go to API management, for example, if I needed that. And then I can use any version that is published by Microsoft. Like I can use the latest, but I can also use all the ones if I must have like some specific behavior of all the versions. I click latest, and then I get like that's all. That's my namespace, and those resources now available in my C# program. So my deployment is done. Yay! It deployed everything. The new URL is this. So that's a URL of a service running in Kubernetes. Let's just check that it works. And it does. My custom image is now running in Kubernetes. So that's my demo. Let's just jump back to slides for a second. And whoopsie. So just a final note, everything that you saw in my demo is open source and free to use. You can start with Pulumi today in your organization or in your private projects. And if you want to learn more about either Azure or .NET support, you can go to pulumi.com/azure/.NET to learn more and get started. And that's my presentation. I'm happy to answer any questions.
Thank you so much for that wonderful presentation. We have lots of people chatting in the Twitch chat and YouTube. We've got people dropping onto the Twitter as well. So I'm just going to have a quick look to the Twitter as well, just to make sure some of the questions didn't get answered. But yeah, it looks like we've had a lot of fun as well. And we're just asking, as in, you know, for you as a presenter, you showed off like a lot of code and things like that. Are there places some of the other presenters have like put up their GitHub repo or things like that? Are you sharing some of your code that you showed off in the presentation? If so, where can people find that?
Yeah, sure. So we have a GitHub repository called Pulumi/examples, where there are like 100 of examples. And my example is going to be there today. It's not there yet, but it's going to be there. But there are like very similar examples there already.
I think I found it. So it's Pulumi/examples. For those of you in the Twitch chat, I'm dropping the link in there. And I'm going to see what actually comes up in. There we go. It is also posted in the YouTube chat as well. So your example, I'm assuming that's right, on github.com/Pulumi/examples. Did I find it? Yes,
Yep.
found it. All right, so people can have a look at the code there. And you're also on Twitter, is that correct?
Yes, just my name, Michael Shulkov, is my Twitter handle.
Fantastic. So if people have questions over the next couple of days, they can totally come back in and
Totally,
ask you
yes,
well. We do have a couple of questions about Azure functions, and one of the
All right.
questions coming through is like, why not Azure functions? Why this over Azure functions? Do you have any comments on that?
In what context? Like,
let's get some clarification on the context. It's someone coming from the Twitch chat. So you've asked a couple of times now, why not Azure Functions TechieVan82? So if you would like to clarify that, we can totally ask that question. We've still got a few minutes left. And someone's saying, don't look up, Mish. Someone's put kitty ears on your head. I know, they're pretty cute. So why not Azure Functions for API handling?
all right, yeah, it's up to you. Like, you get access to all the resources in Azure, and you could use Azure Functions if that's your application model. So it depends on like what you use to develop your applications, and then deploying that is pretty much the same process. You define resources and then you deploy them with Pulumi. So you can totally do Azure Functions. You can do app service. You can do VMs. You can do VM scale sets. You can do Kubernetes, whatever is your jam.
Basically do whatever you want, right? So
yeah,
in terms of, so for some of those people listening who maybe aren't sure, again, asking why not Azure Functions, or why not Kubernetes, or why not this, why not that, what are some of the things you take into consideration when deciding which one to go for? Obviously you said, depending on what it's built on, but what are some of the other things that you should take into account when considering which one to go for?
That's interesting, because actually in my previous demos I usually showed Azure Functions as an example, because that's my favorite service, so to say, and this time I just switched around. But like my preference is, of course, like start with the least burdensome services. So I always start at like fast level of services, which are high level that you can get started in no time. Like you don't have to manage any nitty-gritty details of your physical deployment for VMs. And if you can use that, I always prefer to like start with app service or Azure Functions. And then if you have to go one level down to like something like Kubernetes managed by Azure, if you have to go even to the VMs due to some like company restrictions or anything, then do that, but start at the high level of a service that Azure offers to you.
Fantastic. Now, we've only got 1 minute left, so I'm just going to have a quick look while I'll ask a couple of questions that are coming through before we jump over to our next speaker. Let's just have a quick look. Everyone's probably sitting there going, I don't want to ask the question, what about you? What about you? So, as they said, we can find you on Twitter. So, if there's any questions that come through after this conversation, feel free to ask them. And again, we just want to thank you so much for giving up your time, tuning in from Europe. It's the start of your day. So, I'm super happy and very excited that you were able to be here and to share some of your knowledge with us at .NET Conf. So thank you so much.
My pleasure. Thanks for having me, and enjoy all the rest of .NET cool stuff.
We will.